Okay, so hey guys, good evening. Hello Tensors. Welcome to the today's webinar on agent-based modeling, organized by TensorFlow User Group Coimbatore and co-organized by TFUG Chennai and Tamil Nadu and AI Coimbatore. So again, once again, welcome. So I'll be your host for today, Navneet, and we also have Prabakaran in the back end and Maitrian who will be coming to the front line in few minutes. Okay. So before getting into the today's session, I would like to just brief about what we have been doing in the community and just a few intro about the speaker as well. Okay, so if you are watching this, you should be already familiar with TFUG Coimbatore. So what is TFUG Coimbatore is? It's an online community which is kind of sponsored and organized and maintained by the TensorFlow Google team itself. Okay, and under TFUG community, like under TensorFlow communities, we have a lot of different branches, a lot of different divisions per se, like maybe TensorFlow is a group, Google developer experts, special interest groups, and ML working groups. Okay. Uh, so these TFUGs are independently organized, community driven education initiative. So we organize tech talks, webinars, meetups. So we also do online webinars and we also do offline meetups as well. But due to Corona, we are not able to meet you people in person for the last 1.5 years. But we are actually craving to meet you all in person. Hopefully, if everything settles down, we'll get to meet by next year. In the start, I guess. But TFUG is everywhere. Even in India, we are in about 15 plus cities, and we are also in 70. Look, I think 100 plus groups. This is best. It's an old stats, but we are now 100 plus groups, like span across like more than 20 plus countries. So that is what TFUG does. It's purely community-driven education initiative, and we also have ML GDEs. GDEs are Google developer experts who contribute to the TensorFlow blogs, TensorFlow code base, and also do educate people. They talk at tech conferences by kind of evangelizing AI and machine learning and TensorFlow related stuffs. And we also have SAGs, special interest group. So we have a lot of SAGs for different Google platforms like Android, JVM, Swift, and also in TensorFlow. Under TensorFlow, we have Swift, TensorBoard, TensorFlow Lite, TensorFlow for microcontroller, and so many groups formed under SAG. And we also have ML working groups. So currently there are five working groups. One is ML Ops, mobile OS, and JavaScript, explainable AI, and diversity and inclusion. So why I'm just telling all these in the sense, even you can be part of all these initiatives. Okay, so if you want to contribute to the community either as a speaker or as a volunteer who wanted to organize things and take it across your network of people as well, you can reach out to us on Meetup. You can DM us, myself and Surya. And of course, you can become an expert. If you are an expert, you can apply for Google ML GDE and SAG, and ML working groups are only accessible to GDEs and TensorFlow organizers. Of course, you can start with collaborating with the existing organizers, and then you can become a part of these teams. Okay, fine. So focus areas, what we do, we focus on TensorFlow core product like Keras, the TensorFlow engine itself, and TFGS, TF Lite and Extended, and other related products like JAX, TensorBoard, TF Federated, TF Probability, recommendation systems, and a lot of stuffs. And still there are a lot of tooling and hardware available under TensorFlow like Google Colab, TPUs, and Google Cloud Platform. And we also discuss general topics like today's agent-based modeling. It's no related to TensorFlow, but it comes under machine learning and AI. So we'll also touch base on other traditional techniques like NLP, computer vision, and still do a lot of deep learning as well. So that's what we primarily focus. Primarily, we cover all the AI related stuffs. So if you are not from Coimbatore, so mostly these days we are doing online. You can join from anywhere, but if you're not from Coimbatore and still you wanted to be a part of a community in your state or your city, these are all the 15 plus cities where we are currently functioning. You can join them. Our major platform is Meetup, so you can join us through Meetup, right? So why communities? Of course, learning, sharing, getting feedback, recognition, networking, getting hired. So community is what helped us in learning stuff, helped us to uh, work on cutting edge technologies, helped us to get a job, get a new opportunity. A lot of startups have been formed through meeting people and brainstorming ideas. So yeah, so especially in this fast moving technology world, you can't learn everything on your own, right? So you need to share knowledge, you need to learn from others. So that is why these tech communities exist. Of course, you can be a part of these communities by like in any sort of things, as I've told in the previous slides. So as of now, in Coimbatore specifically, we have two communities. One is TFUG Coimbatore, another is AI community, AI Coimbatore. You can find us on Meetup. You can easily search us on Meetup and join over there. So that's it. So yeah, so we are all on major platforms. So we have a closed group in WhatsApp and Telegram as well. Of course, you can reach out to organizers. We will share links to those groups as well. And these are all some of our physical events happened last year, March 2020, I guess, at ThoughtWorks Coimbatore. So I'm very what to say. I'm missing those days where we have. Chats, and we have stickers, t-shirts and pizzas, and still do development and lots of learning. So hopefully we'll get to we'll get to meet you in person pretty soon. And these are all some of our volunteers. Without these people, our community wouldn't exist. So they help us in poster design to networking and reaching out to people, and marketing and stuff. So not commercial marketing, of course, sharing the news to a wider audience. And these are all some of our mentors. Of course, you can be also part of this core team and the mentor team. And myself and Maithin, we are leading these communities, and you can reach out to us anytime. And without any ado, let's get to the today's topic on agent-based modeling using Python, presented by Prabakaran Chandran. So Prabakaran Chandran is a young data scientist. He's working as a working as a data scientist at New Sigma. Okay, and he's also a tech speaker. He's quite popular in Clubhouse and also in LinkedIn. So he have more than 10K plus followers who are wanting for his content every day. So he produces good quality content and shares online. And he's also very much interesting in sharing his knowledge and empowering other people. So happy to have you on today's session. And the stage is yours. So Prabhakaran, give me a minute, I'll pull you on screen. Yeah. Yes, Prabha, the stage is yours.
Yeah, can you give me 2 minutes so to load the
Okay.
content? Okay.
Stay tuned, guys. Prabha is kind of working on his slides and screen sharing. So give us a couple of minutes.
Yeah. One second.
So regarding the timing, it will be a 1 hour session. Right from it's already 6:10. I'll continue till 7:10 to 7:15, and for the last 15-20 plus minutes, we'll have Q&A. So you can drop your questions on YouTube chat box anytime. We'll pull those questions on the screen, and Prabhakaran will try to answer those questions. Okay. So yeah. Yeah, Prabha, are you ready?
Yeah, yes, yes. So sorry, like my Google slide was like having some glitch. That's why like like, 1 second.
Not a problem. Take your time.
Okay, I'll share this. Okay, let me know if it is visible.
Yeah, one second. I'll add it to a screen. Yeah, it's visible.
Okay, okay. Shall we proceed?
Yeah, yeah. Continue, continue. You're on.
Okay. Oh, okay. Good evening, everyone. Myself, Prabakaran Chandran. I work as a data scientist in New Sigma. So today's topic is introduction to agent-based modeling using Python. So um, yes. So let's consider these kind of places or situations. So places like supermarket, places like pilgrimage, temples, or even like places where we are working, like our workspaces. And right now we are living in a pandemic situation. So and we could see birds are flocking, they are migrating, and animals are herding from one place to another place. So these kind of area, we could see one common thing, which means a shared behavior, or is it a common behavior that has been seen across individuals or entities in the particular situation. For example, if we are in a supermarket, or if we are in a workspace, we'll be having some behavior, which means like we might buy some products, or we might search for some products, and like we might be like sort of like attracted towards products which has more offers. Likewise, this particular behavior, which is like running behind the offers and searching good products, searching new products, will be common for many of the individuals in that particular place. The same way, if we are living in a like a pandemic period, our activities would be like common across common with others also. Whereas like we used to wear mask, we used to follow some SOPs of COVID, we used to follow some safety measures. The same way, when you see the birds flocking, uh, their communication and their activity will be common. Why is this exist? First of all, what are we trying to say from like understand from this particular particular situation? One thing we could understand, there is a relationship between individuals, and there is a relationship between an individual and the situation that makes everyone to act in a common behavior, irrespective of anything, and irrespective of any kind of like controlling authority. So this is how everything is happening. Like you can imagine, we are studying in a school, or we are working in a college, or we are buying particular product. So this could happen for any entities. So let's consider, let's take any particular scenario. You can imagine that, but that scenario can contain human beings, and that scenario can like that human beings are like animals, birds, or any kind of active elements. The active element means that active elements could be an insect, or that active element could be a sensor, or that active element could be a machine. So they can interact each other. So a human being can interact with each other, right? One person can interact with another person. The same way one bird can interact with another bird. Likewise, the interaction is happening, like how we are doing this webinar. I'm interacting with you, and the same way, like you will be like interacting with others, or like you can ask your question in the chat box. Likewise, like there is some activities going on, right? The same way, we the entities are the active elements in this environment, like impacted by few other entities present in the scenario. So that entities could be some atmospheric conditions or environment related variables. For example, if we live in a city, the traffic could be one particular entity which can impact ourselves. Our COVID is one another entity which can impact ourselves. Climate change is another entity which can impact ourselves. Likewise, like that entity can be anything, but that entity will have some impact on the active elements, as in the human beings are birds, kind of thing. So this is a scenario. Let's imagine the scenario as a city. For example, we are living in a particular city. So in that city, the pandemic is there. So we are living in some Chennai, Coimbatore, or any, like wherever we are living in, there is a pandemic right now. So we can roam in the city, right? Like as a human being, we can roam in the city, and I can talk to people and walk with them. I can interact with them. Likewise, I have a freedom to do everything. So I can use a particular service in that city, or I can use this entity in a particular city, right? So these kind of interaction I can uh, I can do. I can contribute to the city. Like I can uh, kind of take some service, or I can provide some service. I can run some shops. Like this, you can imagine yourself as a human being in a particular city, right? That's how we are in, right? And this is not only happening for us, not only happening for myself or a particular individual. It will happen for everyone. For example, here we have some set of people. So for everyone, this is happening. Like they can live, they can interact, they can talk to anyone, they can provide any kind of services. Likewise, this particular behavior is common for everyone, right? This is what I have mentioned in the first slide. So wherever we are in, wherever situation we are in, as an active element, we will feel a common behavior or common interaction with the environment as others. Others will also feel the same, right? So like there is one common thing, like beyond all the behavioral aspect. I can walk a particular time span, whereas another person might sleep, right? But one common thing will be there, which is virus spread. So this particular virus spread is actually changing everyone's activities, because like previously, without any kind of pandemic, the living style or kind of activities uh, like might be different than what we are right now, right? It's purely because of virus spread. Based on the virus spread stage, we could see like kind of activities change, behavioral change of the human beings in the city, right? This is how a city is looking like right now. If you take any kind of cities, this is the reason, right? So in this moment, uh, so right now we are seeing entities and human beings. What if some a third party, or like uh, some some sort of controllers are coming inside? So in that situation, like a government wants to understand the COVID spread. What is the situation? Like how this COVID spread is actually being there, and what kind of control measures that we can take up, or like what is the characteristics of that particular dynamics of that particular spread. So likewise, there would be a lot of questions, right? Like to understand the spread, so that like our government health department, if they have the understanding about the behavior or dynamics of the COVID spread, they can take decisions. The same way, you can imagine all these things in terms of a parallel world where you are a consumer and a company wants to understand your behavior, so that a company can take a measurements to make you happy. Likewise, you consider yourself as a employee in the in an organization, whereas your employer understand your behavior so that they can roll out some policies to make you productive. The same way, you can imagine n number of places where an environment is there. The same way, we used to imagine a reinforcement learning, right? So the ultimate aim of the reinforcement learning is different, but that scenario, that story ground is common for agent-based modeling and reinforcement learning. In agent-based modeling, we have agents, which means we have living active elements, and that active elements will be there in one particular situation. The same way, in reinforcement learning, there will be one active element that will be continuously interacting with the situation. Based on that, it will take some rewards and act accordingly, right? But here, that's the reason. Like, you can imagine in a number of way, but here, to put it in the like in a real time manner, I have taken this COVID spread as an environment, and in that environment, we living beings are there, like human beings are there. So they want to understand. But one thing, to understand these things, like they need some methodologies how to do that, because we are saying, okay, there will be if you take a city like Coimbatore, or if you take a city like Chennai, there will be like lakhs of people, like minimum like 50 to 1 crore people will be there. We cannot monitor everyone, we cannot measure, we cannot receive the data from everyone, right? We cannot do such things. But what we can do is we can simulate something, which means we can like mimic this particular environment, mimic this particular scenario in our computer, which means in our machine, so that we can try to like replicate the behavior and dynamic aspect of the city and the movements of each and individuals. So let's see what are those elements. Like we could see some human beings, we could see some entities. They are active, they are interacting with each other. So in such situation, what is actually happening? Like, what are we trying to sort of like understand? So that is what like we are going to see in this next slide. So as I said, like if you see this particular environment, we could see one particular one sort of like a living human beings and entities. The entity could be anything, as I said, like that could be a spread, or that could be some sort of some sort of government agency or a service, or it could be anything, right? So individual in the city, individual in the city is the granular active element, because like other than an individual, there won't be any other granular element. Granular isn't like a very minute element. So the, uh, the the least in hierarchy is in the individual. We can call this individual as an agent. Why? Because that agent has some separate behavior. He will be interacting with the scenario. So we consider this as a common term called agent. The same way in reinforcement learning, we have a common one particular active element which is going to interact with the scenario, and which is going to learn that strategy to win that particular scenario, right? That is what called as agent. The same way here we have an individual which is a granular level, will be called as an agent. So there can be an interaction between two agents. So that interaction can be anything in real time. Two agents can talk, they can interact, they can even transmit the COVID. So without by talking and by interacting and all, there won't be any such uh, any such difference or impact on the COVID spread. Whereas if they just kind of like interaction, as in like when they come closer, when they spend some time together, right? There might be possibility of COVID transmission, right? That's how the transmission work. It is directly from one person to another person. It is not through the air. It is from one person to another person. So if there is a distance, like very like a kind of like a very less distance, obviously there is a possibility of COVID transmission. So likewise, we could see that um, uh, some sort of interaction between and two agents. And there is another sort of interaction, the interaction between an agent and the elements of the city. So the element could be anything, like the element could be the places where, okay, I'm an agent, I can go to a hospital, so that interaction will be something like, okay, getting cured from the COVID, or like if I'm going to some particular mall, that interaction could be like the probability of getting infected will be increased. Likewise, there will be a lot of chances are there, right? Because like there are n number of possibilities. I can do anything in a particular city, and there may be some policies. Policies would be policies are nothing but some SOPs we have, like, okay, we should wear mask, we should follow some sort of like a mask, we should follow some social distancing, and like we should not go out unnecessarily. Likewise, there will be some policies that are possessed by the individual agents, and some regulations could be like a lockdown, and a vaccination program. Likewise, like there will be a lot of regulation which is going to control the environment, the whole environment. So when there isn't a regulation, or when there isn't a policy which is an external factor, obviously there will be a interaction, or there will be like a behavioral change in the agents, right? So this is how we could see different components, and we could see different interaction present in the particular city. So the entire city comprises above elements, right? So we could see that there are different types of agents and different types of entities and the interaction among them, that is available in one particular bounded area, right? One particular city. That city can be called as environment. So we talked about the agent. What is agent? That is an individual granular element, and we have seen the environment, which is a place which comprises of everything, and within that environment, agents can play around. They can do whatever they want, right? So this is how we are defining the agents and environment as reinforcement learning as others also, right? So where are we, like, so okay, we have agents and we have environment. Then what is what is mean by that agent based modeling? uh, so right now we have this agents and environment, right? What if we could simulate the interaction at various levels? So there will be set of properties which will be belongs to an agent. That particular agent can reside in an environment. So the properties is nothing but that particular agent could be an infected person or uninfected person, or that particular agent could be a masked person or unmasked person. Like this, there will be n number of properties. Because of these properties, we could expect the interaction across different agents. For example, the interaction between an infected person and uninfected person will be something sort of transmission of the high risk of transmission of the COVID. Whereas the interaction between infected person and a masked person, the transmission will be very less. So there will be like n number of interactions, and that interaction will be like a kind of a distribution. They have its own like properties, or like some magnitudes. The amount of infections, or like getting infected or getting cured will be there, but it is all running around agents, and all those agents are an environment. So the agents could be anything, like they could be human beings, where the interaction and the characteristics of that interaction will be in one particular distribution. Whereas the frontline workers, the scenario will be completely different, because like they have high vulnerability of getting infected, because they are frontline workers. They are like walking very close to infected persons, and they are providing like life-saving services and all. So in that situation, like based on the agent's type, we could see different types of changes. So that's why like we have different set of value, different set of properties for an agent, and they are in the environment. If we are able to simulate them, if we are able to simulate them, we can exploratory analyze different scenarios, and we can get the overall insights about the environment. That is what our aim, right? Because we have a government authority, we have a health department. They want to understand the scenario, so that based on the scenario, they can play around it, they can understand, and they can like take some policy measurements so that they can reduce the COVID spread in the city. So it's going to be the feedback, like whatever we are understanding, whatever we are simulating, based on that there will be some output. From that output we can take some decisions. That decisions will impact the environment in real. This feedback is going to be common for any scenarios that you are going to take. Like even if you are going to a pilgrimage, that's why I put that Sabarimala image in the first place, because that is a one common case study, like one benchmark case study, which is crowd management in pilgrimage areas, and that too during the COVID situation is one such like benchmark case study. Why? Because there will be COVID spread, and also there is a common behavior among devotees, which is like they always like wanted to reach that main place where they can do some sort of like a prayers or all, like that source to destination behavior will be common. That might change in magnitude, but behavior is common, right? They will be waiting in queue, and if there is any gap, they can try to like penetrate that, and try to get close to the destination. Likewise, if you are like in a marketing world or in a consumer world, all the consumer will possess the same kind of behavior, like to get the to buy the product, to interact with the offers, to interact with the new products. Likewise, there will be a number of behavior aspects, right? But that behavior aspect, the magnitude will change based on the demographics, based on the personal behavior and all, right? This is how the elements are looking like. By understanding these elements, we can take a lot of decisions out of it. This is how like research institutes are taking measurements, are planning such things, like either it could be a crowd management, or it could be a new product launch, or it could be a marketing event analysis, or it could be like a city planning, everything where the people are actually simulating. Like you would have uh, uh, like watched some series, and there people will talk about this controversy theories and all, right? Conspiracy theories and all. The world is a simulation, like everything is being simulated by something. The same thing we are doing it in a minimal scale, which is for one particular scenario, right? So how can we do that? Actually, we can do that using computation only. We are going to do that. But uh, what is this? What is this particular simulation? So this particular simulation is what we are calling as agent-based modeling. We know what is agents, what are they doing, and what is the limitations of that. So the proper definition for this agent-based modeling is going to be like uh, so agent-based modeling is one of such computational models. So we have a lot of computation model, right? Like in this artificial intelligence, data science, the world of computation, intelligence. We have like multiple methods. One such method is agent-based modeling, where we are always like want to sort of simulate the actions and interactions of the agents, like whatever individual is doing, and whatever individual is interacting with the other agents. So this is the computational model. So this computation model is mixture of game theory. You can imagine that how these dots are interconnected with each other. Game theory. So game theory is nothing but it's going to like play around how players are, how individuals are taking decisions. The same way here we are going to understand how individuals are taking like interactions, are taking actions within an environment. And we have complex systems. Complex system will have n number of like entities that will have like its own states and behavioral aspects. The same way here we have in the city, there is hundreds, thousands, lakhs of agents. Lakhs of agents has their own like attitude, own behavior, and also they have some sort of interactions with the elements, right? So and it also like connects with the sociology, right? Because we are studying about human behavior. We are studying about the collective behavior of one particular group. Either it could be a a human, or it could be an animal. Even if you take that bird flocking, so you could see like without any leader, like, there won't be any kind of leader in that group, but they are like organizing themselves, like self-organizing nature is there. They are like interacting with each other so that they could easily reach out to the place where like enormous amount of food is available. Or if you take an ant colony, that ant colony is like intelligently planning their path so that they can easily reach out to the food where they are getting food in an easier manner and in a quicker manner. Likewise, you could see this common behavior and collective behavior and the interaction in various places. So that's where the sociology to understand this kind of collective behavior comes in. And evolutionary algorithm, like when you consider this genetic algorithm, or if you consider a particle swarm optimization or swarm intelligence and all, where we get inspired from the biological or like a natural like activities or natural elements, we could use that for solving a particular industry problem or solving particular business problem, right? So this agent based modeling is a mixture of everything. We could see that, right? Like decision making, collective behavior, complex in nature, and trying to solve problems. So this is sort of like what is that like that mixture. And it has been built on top of discrete event simulation. So discrete event simulation, we know that in discrete event simulation, time is going to be discrete, and that is going to be an atomic, in which like for a time instance one, what is the status. Discrete event simulation we would have studied in the SymPy, Python SymPy one, or like if you're actually simulating some inventory related things, or some business processes, we would have studied that. It is one of such good thing in machine learning, sorry, the data science based um, case studies. Simulation is also matters, not only modeling or not only predicting something. It is like simulation will lead us will give us the actual essence of prescriptive analysis, right? So the brain behind the simulation could be anything. Like it could be a heuristic rule, or it could be a linear regression which is driving that whole simulation, or it could be some probabilistic model which can which can lead to take some decisions of a particular agent. Like this, the brain could be anything, but the aim is to capture the events, right? So it is built on top of discrete event simulation. And obviously this will give the exploratory analysis of the system. If you take a city as the system, the city in the COVID as a system, we could ensure we could get the in-depth analysis of this system, what is happening, why it is happening, and you can play around it. Like it's like a control panel. You can increase the one particular variable and see how agents are actually behaving. Like as you can do, it's not only for a COVID pandemic. You can imagine for consumer analytics also. You can increase the offer, or you can increase the advertisements, and you can see, okay, what would be your revenue, what would be the profit, so that you can take the business level decisions. And it is going to be a data driven behavioral understanding, instead of just playing around, instead of just like saying, okay, this will happen, instead of just saying that as a heuristic approach. There is a possibility of including data driven behaviors, which means like we can incorporate research studies, as in like what is the status of transmissibility of COVID, or what is the COVID mutation ratio, or what is the behavior of infected people in hospitals, or what is the kind of like probation period, or like infection period for particular COVID impacted patient. Like this, there could be any number of data driven elements would be there. Utilizing that only, we could actually like replicate the real time scenario. Otherwise, it will be like a toy, which is like which will not be mimicking or like replicating the real life scenario. Rather than that, it will be like just playing around classes and objects. That's it. And it is a computationally heavy, and we need more infrastructure for agent based modeling. For example, for now we are just utilizing like very very limited amount of agents, which is not actually replicating a real-time environment. Whereas organizations, research institutes are actually doing its day in and out. They have infrastructure, GPU clusters, where they can run for years or for a particular months, each and every minute or each and every hours, for like lakhs of agents. For example, if you are in a city planning research kind of projects, there, if they are planning for traffic congestions, or even if we are in a research institute which is doing this kind of COVID related studies, they will be like taking minimum lakhs of agents in a particular city, and they will be evaluating, and they will be like calculating these interactions for each and every agent in the particular city. So this need more computation, right? Because like lakhs of agents, individuals has to be computed for each and every timestamp. So if you just think like one day, and if you are doing this like computation for each and every minute, so it will be like 16 to 16 to 24, right? So that will be like huge computation will be required, right? This is the overall picture about the agent based modeling, but we still need to look into like very granular information about like what are we doing it, like like how do we define such kind of like agents and properties and all. So if you take any one of the agent, that agent distribution can be decided by census data. For example, if you take one particular like one particular city, we cannot just randomly distribute agents, everyone as a like male agents, or everyone as a female agents. Like there will be some distribution. Okay, 40 percentage will be females, 60 percentage male, and in that also there will be like distribution of age, right? Where 5 to 10 will be like 10 percentage, 10 to 20 will be like 10 percentage, 20 to 30 will be like 25 percentage. Likewise, the distribution will be there. That distribution can be, that is why like I said that, right? Like this is data driven. This distribution can be decided by census data. Okay, this is one thing. And another one thing is different status of agent. For example, if you, so there will be n number of states, right? I might be sleeping, I might be walking, I might be like chilling out in some restaurant. So there may be n number of status, but what is needed for the study, what is needed for the analysis, is whether I am susceptible or not, whether I am infected or not, whether I am recovered or not. These are the common thing, right? Like when we are doing analysis around COVID, these are the common behavioral aspects, where we will be concentrating only on whether the person is infected, whether they have a chance to be infected or not, whether they are like getting recovered from it or not. Like only 3 or 4 will be having, right? That will be like a domain centric. It's not like a normal activities of human beings. And the behavior or interaction between agents can be decided by extensive study, which means like, for example, if I am if I am an agent in a city, and the interaction between one agent to another agent, for example, the transmissibility. For example, I am interacting with one particular agent. Like, what is the probability? Will he be infected or not? Likewise, that behavior, that interaction can be decided by extensive research by any other entities also. It could be like some other research institutes, Imperial College London, or it could be John Hopkins University. They'd be doing some people-centric like research in COVID spread, like how this infection rate is changing, how this transmissibility is actually changing, how this exposure time is actually changing. Likewise, they will be that they will take a lot of research, like which means survey. Based on the field survey, they will have some heuristic, like sort of equations or sort of conditions. Okay, this is the condition of transmissibility between two agents. Like this, that will be there. And the same way, the behavior between two agents, sorry, agent and the environment, can also be decided, which means like what is the probability of one particular person getting vaccinated in a particular day, or like what is the probability of a particular person comes out during the lockdown. So this huge thing, right? The interaction between that agent and the regulations or policies that we are making will also be like taken by the like extensive research. For an example, I personally did one project like professionally. I was in a project which was like understanding the consumer behavior. In that, we utilize like tons of consumer research, market research data provided by market research companies. For example, like Conter, or for example, Nielsen. So they have done like lot of consumer basic research. From that only we could understand, okay, this is how a particular person like who lies in like a 20 to 30 years old, who is in between 20 to 30 years old, is behaving in morning, behaving in the evening, behaving in the night. What is his preference, how he's like interacting with the like advertisements. So that particular information, that behavioral interaction related information, is being collected by that research institute only. We use that data and try to like create agents behavior the same way. If we could like I'll get these details from Google mobility or Apple mobility data, or normal government databases, and research institutes results. So it's an extensive project. It's just not going to be a single man project, because if I am just doing the project in my local, that will be like just a playing that will be like just building the Lego boards. But actually we wanted to build a palace which will create an impact, right? That can be done only with the help of industries, or only during the professional projects only. Luckily I got the opportunity to do that, to understand the ability of agent-based modeling and the ifs and buts of agent-based modeling. And another one thing is like the environment, the whole environment. Like, okay, we have behavior of agents and behavior of environment, and we can control these environment events either by user or admin. Events, as in like the controlling events, as in nothing but like I can impose lockdown, I can impose some sort of policies like vaccinations, or social distancing, or some sort of SOP I can roll out. So these kind of control that I can take. It's the same way you can take this control in consumer analytics, like sort of like advertisements or offers. The same way in finance, economics, like what is the government policies, how this government policies is going to impact individual agents. So that individual agent going to be in industry, in economy. Are the individual agent going to be like farmers, if you are just concentrating on farmer GDP, or if you're concentrating on a consumer expenditure. So based on this inflation rate, how this consumer expenditure is going to be affected. Based on this particular pandemic, how this consumer expenditure is going to be affected. Like this, we can simulate in like finance, or we can simulate in economics also. So, like for example, this I said that, right? Like this behavior can be sort of enabled, defined by the extensive research. One such research is like one such a simple like during the pandemic and all we were talking about, right? One infected person can cause infection to 2.6% or 15% or 30%. There might be number. So that number is from that descriptive condition is completely from proper research done by some entities, like some research institutes, some hospitals, right? So we can use descriptive equations or probabilistic model that can be used as a brain, or that can be used to enable the behavioral part of an agent. So an agent is going to be just an object without defining any kind of this kind of behavior. He will be just, okay, I have one ID, this is my ID, my age is this, my type is like a human, like normal, like common man, and I live in this particular city. So it's just going to be properties, there won't be any kind of behavior, right? So to enable that behavior, there should be some brain, some sort of like there should be some formula, or some sort of like some design should be there. So that could be a descriptive equation, which means, for example, a descriptive equation to define the transmissibility. So here that interaction or whatever behavior aspect is going to be transmissibility only, for a simplicity, right? So to define that interaction between two agents, the transmissibility, we can just take a single descriptive condition of 2.6 as a rule, which means like 2.6 is nothing but like if a person is like if the person is interacting with other agents, from that interaction there is a possibility for 2.6 people getting infected. For example, you can round it off, three agents get infected from the one infected agent. So this is how the infection the transmission will expand. Okay, 1% to 3, that 3% to like extra number of people, right? This is one such thing. And here we are not considering any such external factors. We are just considering whether we have like whether we are actually like interacting with others or not. If they are close to each other, they will be getting sort of infected. That is the only thing that we can do. But whereas in Bayesian network based analysis, this is what we have used. I have personally used in projects, because where we have n number of elements that is controlling consumer behavior. The same way, like to incorporate more influenceable factors, a conditional probability based Bayesian network. Here come that machine learning or a probabilistic learning based data science elements are playing major role, in which the core of ABM will be defined by the Bayesian network, which means like a probabilistic network. So each node will have its own conditional probability. For example, I am a particular agent. The infection probability will be depend on how much vulnerable I am, and what is the vaccine status, and what is the COVID SOP that I'm following. So this is completely subjective that I have put it for this particular talk. And there could be n number of like there could be like 20 or 30 number of factors that can influence, and that relationship between the factors can also be defined by extensive statistical analysis. We literally spent months to perform hypothesis testing, months to perform EDA, to ensure the relationship between different agents. For example, in consumer analytics, are like if we want to understand whether the particular person will purchase this product or not, this purchasing product is actually influenced by the demographics, the customer loyalty, the interaction to the advertisement, and what is the new offer. The same way, the vulnerability here I have taken is going to be dependent on the age and the comorbidity. So if I am based on the combination of age and comorbidity, the vulnerability can be checked. For example, I have sugar pressure, I have some sort of lung disease and kidney related issues, and my age is 50. So that vulnerability will be like high, because like in the age of 50, if we have like more number of diseases, prolonged diseases, obviously that will increase the vulnerability of getting infected, and that vulnerability of like severe infection will also be there. Whereas like the probability of comorbidity for a youngster is very less. In the same way, the age is also like it will be like 12 or 13, or it will be like mid 20s, right? So by comparing the age and the no such comorbidities, obviously the vulnerability will also be very less. And if we have less vulnerability, and if we have like if we got 2 jabs of vaccines, and we are following COVID SOP, obviously the infection probability will completely less, right? So you can ask like how I am like bringing this conditional probability. It's completely based on the field report only, field survey. Like we can take some sample of a city. For example, if we want to do this like simulation for Coimbatore, we can take some 1,000 people across different zones of Coimbatore, and we can collect the data. Okay, what is the age, what is the comorbidity? That data is actually available available with government, because they are actually recording it, right? Like whoever getting infected, that age, their comorbidity conditions, whether they have gotten vaccine or not, whether they have followed SOP or not, or like what will be the reason, like whether it is like whether it is from like unknown contact, or it is from some clusters. Like this, there will be a number of data points that we can collect from the government authorities. So from that we can establish this particular Bayesian network kind of thing, and this will define our agents behavior based on the different scenarios. This is one thing. But in our use case, most of the time like people are like just utilizing the online available research results, and they are utilizing that as a behavioral aspect, like to define the descriptive behavior. This is very less, and this will take more time because we need to model this particular Bayesian network, right? That is there. Okay, so okay, we have defined the uh, behavior of agents, and how are we going to build the simulation? Like, how are we going to run the simulation? So the first and foremost step is going to be initiate the population with desired characteristics. So the population could be a number, like some thousands of people would be there, and we can define the time span and interventions. So time span could be like, okay, we wanted to simulate only for this particular week, where a lot of holidays will be there, and a lot of festivals will be there, and the intervention could be like we are going to run 10 vaccination camps, and or we will be like putting lockdown after 10 o'clock. We'll be limiting the movements after 10 p.m. in the night. Likewise, the intervention can be there, and we can define the environment. And once we define that, for each and every time step, for each and every agent, the agent should take some movement, right? Movement as in the position should change. Why? Because agents will continuously active in nature. Even I am just lying, my activity should be updated. Okay, activity doesn't change for a particular agent, so that should be there. And based on the activity, based on the movement that I have taken, that interaction has to be calculated, whether I am close to infected person, or I am an infected person and I am close to others, or I am transmitting COVID or not. Likewise, this particular interaction has to be checked, and that has to be calculated, and that has to be updated. This is how, these are the steps, right from initialization. And it is going to be the loop where for each and every agents we will be doing the position checks, and the movement and the activity interaction update and all. So once we, so this is the different steps. And here I have some scenario. So this is the shared environment. Here we have like n number of people, like n number of agents, where only one particular agent, here we could see, right, this particular agent is infected, and here this guy is like recovered, and he has some immunity, for example. So this is time instance 1. So we just have this everything is initiated. So in the time instance 1, we could see there are three individuals are in close connection, like within that social distance. For example, if we follow some 5-meter distance, there won't be any possibility of infection. Whereas, like if we are very close to each other, the possibility of getting infected is high, right? So that interaction will happen, is going to happen, because we are like the agents are close to each other. So that interaction is actually happening. The interaction is nothing but the transmission of COVID disease. So because of that, in the timestamp 2, extra 3 human beings or agents are getting infected, right? Because of that the interaction. So, and in the time span 3, they are moving, because like once they're getting infected, they won't know in the upcoming days, like as soon as they getting infected, right? So they are moving as usual. Because of their movement, the next set of transition is actually happening. You could see that this particular person is interacting, which means like meeting the another person. Likewise, it is happening. And we could see this particular person has infected another one, right? And another person like caused the infection to this particular agent. And this particular agent didn't get infected. Why? Because he get sort of like vaccine, so he has the immunity. And the old agent, like the previous agent, get cured because the time got like he get some treatment, or he get some time to get cured. The same way he didn't get cured. Why? Because like it will take some time for him, like, so that the curation time, that recover time is not same for everyone. That will take like that will vary like 7 weeks to 50, 7 days to 15, based on our health conditions, right? And some people wouldn't have infected, or wouldn't have needed any kind of treatment. Why? Because they have good immunity, right? So that is the reason this particular agent didn't get infected. Whereas even like since this guy has lesser he's weak in nature, that is why it is taking more time to get cured, right? Whereas like this particular agent get cured in 2 timestamp itself, and the same as this one particular agent, right? So this is how for each and every timestamp the movement will continue to happen. Like the agents will continue to interact with each other and try to transmit. So it's not trying to transmit, it will automatically happen. So agents won't control anything here. The major difference between this basic agent-based modeling and reinforcement learning is, I have that slide in the next upcoming slides, but anyhow, like I could say, here we are just inferring, we are just observing, and agents are not actually controlling anything. They are just on the go, self-organizedly. They are trying to do such things, are trying to exhibit some behavior. We're just recording it. Okay, in the nature, in reality, this is how happening. This is the percentage of people getting infected in this week. Likewise, we are getting it. But on top of that, we can build n number of analysis, n number of data science solution. One such thing is like reinforcement learning, where we can just concentrating on one particular agent, and that particular agent can be strategically trained to escape from this particular transmission. Likewise, it is going to be like controlling or making the agents to learn. That reinforcement learning is going to be solving that particular environment. Here we are just building that environment with a number of agents and their behavior. We are not going to control anything. Whereas we are just observing, and we are going to put some it's just a puppet show. We are just going to put some sort of interventions. So because of that intervention, agents will like behave in a different manner, so that we can understand, we can prescriptively taking some measures. Whereas in reinforcement learning, that is, the agent, him or herself, is going to learn something. They're going to adapt themselves. They're going to strategically think and strategically plan something out of it, and to get the more revenue or more reward points. That is how this is the very basic difference in agent-based modeling and reinforcement learning. And there is another such things also, like by utilizing the common behavior. So we could see this behavior, right? Like how this transmission happening. By understanding this common behavior, we can develop an algorithm. That algorithm can be used for some random industry problem. For example, you can consider a gene as an agent, and genes reproducing and mutating can be that environment, the whole genetic genesis, the whole genetical mutation, the meiosis, mitosis, are going to be like the agent only, right? That simulation. Like if we could simulate each and individual agent and their reproduction and mutation, crossover and all, can be just called as agent-based modeling. We are just understanding how genes are actually crossing over each other and trying to produce the offsprings. But we are not only doing that. We are getting inspired from the that nature behavior of the genes, and we are utilizing this behavior to solve the industry problem. That is what genetic programming, right? That is what genetic algorithm. The same way, we are trying to simulate the behavior of a bird flock. How are they collectively travel from one place to another place where they can find food. So that group collective behavior, collective agent simulation, or that behavior, we are using it for solving the industry problem, optimizing the process, optimizing the business outcome. That is what swarm intelligence, particle swarm optimization. So everything is interconnected, from this agent-based simulations to reinforcement learning, evolutionary algorithm, multi-agent systems, and like a number of things are there. So yeah, this is about that simulation, and we'll see. We'll try to see how we can like simulate this using different Python frameworks. I will share my I will change my this thing. Um, um, I'm Navneet. Are you able to see my Jupyter notebook, collab notebook?
Yeah, yes, Prabha, it's visible. Hello.
Yeah, are you able to see my
Yeah,
collab notebook?
yeah, Prabha, it's
Okay.
visible, visible. You can continue.
Okay, got it. So, yeah, I would like to give the how the research institutes have developed an agent-based simulation for COVID-19 to understand the health and economical related effects. So there is some research done by Professor Paterno Candido, um, like um, so this is I've downloaded from the particular git page. I'm just cloning it up. Okay, COVID-19 agent-based simulation. So from that, one second. So yeah, I'm just um, like uh, like starting the simulation. So simulation is nothing but this is very simple. So as I said, that has involved a lot of n number of a programming related stuff. But how it is actually working or what is the use of it? Like I'm just showing using this COVID ABS framework. So here we can define the simulation. So what is the infected percentage of population, which is 0.02, which is 2% of people are just infected. It is just in an initial stage of COVID. And what is the immunity, immunity in initial population, which is like very or like 1% of people has that nature immunity. And this length of simulation environment, it is just to showcase the graphs. And the population size is 80 people are there. And contagion distance, which means to get infected, what is the minimal distance is 5 meter. So if we are less, if we are close in each other, like within 5 meter, there is a possibility of getting infected. And what is the maximum percentage of population that the healthcare system can handle? For example, with respect to Tamil Nadu, we can handle like 1 lakh people per day based on our infrastructure. Tamil Nadu's infrastructure. Coimbatore can handle like 10,000 people or 20,000 people in a day based on these ICU beds and like other normal beds in the hospitals. And what is the mobility right now? Since we didn't like during the initial stage, we didn't kind of incorporate any kind of measurements. So everyone is roaming, all susceptible people recovered from the COVID and infected people, everyone is roaming. So without doing any sort of intervention, without putting any sort of regulations, let's see how this simulation looking like how we can see some wonderful graphs from that, and how this is going to like happen for next 100 days or next few days. So this simulation is running. Meanwhile, I would like to showcase how the agents are being defined. Let's go to this GitHub page. So GitHub page will be having this agents everything defined. Let it get loaded. Okay. So we didn't do anything, but yeah. So this is the simulation. Um, so this is the simulation. Like we could see, um, uh, uh, everyone is roaming freely, and that could cause the contagion. You can see this. So for the number of days, what is the probability of people, like when days go ahead, that infected people, by 30, um, like uh, at the 30th day, we could see the peak with the current status of now what is that, like um, healthcare system. Based on that, their interactivity between the healthcare system and the infected people, we could see that downward trend after 30 days, and the number of recovered immunes will start increasing after 50th day only. That will reach good amount of time after 50th day, and since we just have 80 people, we could reach the good status in the 50th day itself. And another one thing we can understand, uh, who are the most kind of like vulnerable people, the economical impact, who is going to be impacted because of this kind of what is that, these kind of regulations or these kind of pandemic, right? So you can see that the most rich people are not at all not at all getting impacted, whereas most poor people are, their wealth rate or their economical impact is very less, like they are at the very minimal position at the initial days, whereas it has started increasing. So which means, because we could see this, right, the infection number of infection is very less in after 50th day. So after 50th day, this trend could see increase, because like people are back to work, everyone is most of the people are like getting cured from the COVID. Now there is no second wave and all. The economy has returned to its own its normal position. So this is do nothing with just 80 people. So if we could just do this for crores of people, this will not be in one wave, and we are not at all induced any such second wave intervention or any such lockdown kind of things. We are just do nothing, just with the simulation what is going to happen. That is what we are seeing it here. Whereas what if we restrict the mobility of infected people? Let's see what is going to happen. So if I'm restricting, so I'm just changing the mobility of like uh, infected people. So here you can see the mobility of infected people is completely zero. We are completely isolating them, and we are not allowing them to roam around anywhere. So we are just running it. So this will be let's see what is happening. Like we can see the difference between without putting any intervention and with once we implement that intervention. The same population, same behavior of that other environment, everything, but only one thing is we have implemented that limitation. So you can see that this particular peak point. So um, this particular what is that peak point is comparatively less than the previous one. In the previous one, the peak was literally high, which is nearly 80% of people get infected, whereas in the isolated one, we could see only 20 to 25% of people get infected. Why? Because we have limited the movement of infected people, right? The same way, this economical impact is also comparatively comparatively better than the previous. So this is how we are going to play around. Actually, companies are research institutes are playing around by putting some interventions, setting some conditions, and what is going to be the better action. For example, if you have a exhaustive agent-based modeling framework, we no need to we can actually consider the sort of the results from the agent-based modeling framework every time we are taking some decisions. Okay, should we open the malls or not, or should we open the colleges or not? So what will happen if you open the colleges, or what will happen if you open the malls? So which is better? Should we open colleges or should we open malls? Likewise, we can play around it. We can simulate n number of events. We can understand what will be the increase in total positivity rate, or what will be the increase in infected people, so that based on that we can react. Okay, malls will increase the total positivity rate by 20% or 30%, whereas colleges will not impact such things. Likewise, this agent-based modeling will help us in a lot of things. The same way, if you are able to build the same kind of thing with respect to consumer analytics, like what if we could give like 5% offer or 10% offer, what will be the revenue, what will be the sales? The same way for organization, if we could give like 1 day holiday, what will be the productivity? Or if we could like give a 3 day holiday, what will be the productivity? What will be the attrition rate? Right? These kind of individual or agent centric agent-based modeling can help us people to take better decisions. Being a decision scientist in our company, we are we get these kind of problems to help our clients to take better decisions. Instead of just having a model, we can have a framework which will intent help them in terms of taking good decisions around it. Let's have a glance of like how have they defined the agents and all. So in the COVID ABS platform, so we can define our own agents. Like there are a lot of frameworks. Python based frameworks are there. Python NetLogo, Mesa is another one. Like environment. So the n number of environment is there. Like if we have the business heuristic, so obviously we should have some conditions or equations to define the heuristics and define the behavior of the elements, right? So if you see that agents, it is going to be just in a class only. So the agent can be like that. What is the infection severity? So for example, one second. This is an agent. So for a particular agent, we have ID, and we have position x1 xy axis, and we have the health status, whether they have asymptotic or symptotic, or whether they are susceptible or infected or recovered from it, and the infection time. We have age, so age based conditions we can use, and what is their social stratum, whether they are wealth or whatever it is, like working professional or not, what is their wealth, in order to understand that this thing, and what is the type of agent, right? Likewise, we can define the properties or characteristics of the agent, and based on that we can continuously update based on the conditions. Okay, if they are close to infected people, and if he is like a 50 age, and he is sort of like what is that, like infection rate is like 5% or 10%, that status will be changed every time for an agent. So that we can see in the simulation part. So here we have ABS, where we are defining the simulation. Okay, yeah. In the simulation, we have this population size, length, infection percentage, and everything is there. As I said, like I told you that, right? For each and every timestamp, for each and every agent, we will be doing the analysis, right? So yeah, we can see this, right? So when we execute for each and every agent in the population, we will do the movement. So this movement will trigger the will trigger something. Trigger as in like it can trigger one person getting infected or one person recovered from that thing, right? Like this is the movement. So for each and every movement, we will get the update. So update is nothing but like what is the status, new status. Likewise, that will happen like for every agent depopulation, and that will be updated in the like a data structure, and we can use it to showcase in the graphs like this, like this we can do. So if we have a proper heuristics, if we have proper research based equations, we can build this agent based model as close as possible instead of just having the random one. I would suggest you to read more upon that. Like I hope like I've given a sort of like introduction to that, like what is this like agent based model, and how can we utilize, where can we utilize those kind of things I have given. Like if you are interested in that, you can start learning it, and you can view, you can check that GitHub profile portfolio of that particular COVID-19 agent-based modeling framework to understand how this code has been constructed. Because that, if we know about that process, we can easily construct the code, because it's just going to be play around um, like um, like classes and objects with the heuristics. And sometimes we can replace the heuristics with research based equations, or some probabilistic or even regression model we can utilize. For example, if you are building agent based modeling on supply chain, you know like how the movements of each and every truck will happen, and that movements of that goods will happen. Like you have some sort of like regression model, you can use it instead of just having a heuristic approach, right? So we have some nearest neighbors of agent-based modeling. One is multi-agent system, in which we wanted to study about multiple agents, and multiple agents are going to collectively learn and solve that particular environment. And reinforcement learning, we discussed that, like how it is differing from the agent-based modeling. It's nothing but like in a reinforcement learning, one particular agent is going to learn that strategy to win that situation, right? And evolutionary algorithm is like replicating or inspiring the behavior of the agent simulations, and using that to solve the particular problem, business problem. So these three things are mainly like built around the behavior and activities of the uh, agents. And there are n number of applications. One is like as I said, in the business perspective, consumer behavior modeling in CPG, retail, banking. Like these kind of applications are getting more traction. In the same way like the city planning, traffic congestion analysis also there. And like so we can simulate this supply chain, and we can use it for optimizing that, and production scheduling. And the same way for animal plant interaction, food production, and epidemiology modeling. That is what we have seen in the example. And the same way I told you, right, like the workforce management to understand the attrition rate and performance of the employees, that can also be done. Yeah. So like with that, I'm done with the explaining things. Like if there is any questions, I can I can take that up in next some 5 to 15 minutes.
Yeah, sure, Prabha. Thank you so much. I think you have a runny nose and
Yes.
having some illness, but it's okay. You have done a tremendous job. It's really good. It's really interesting topic as well. Yeah, so with that, we'll take up some questions from the audience. But before that, I have some questions to get it answered. Um,
Okay.
so first thing is, if someone is like, okay, so how agent based, like, see, you take AI and machine learning in these days, people right away they try to learn some regression technique, decision trees, and deep learning, computer vision, NLP. So people mostly are biased towards those kind of technique, right? So,
Yeah.
how does these evolutionary algorithms, statistical models, agent-based modeling and other reinforcement learning. So how it differs from uh, those hypes, and what's the learning path if someone wants to become a good data scientist? So what are the skills they need to acquire, like not in general, respective to this agent-based modeling and other classic algorithms?
Okay, got it. So the thing is, like you said, right? Like we have some, like we are running behind the hype, running behind the buzzwords. But with that, like we are missing actual impactful stories. Whereas like agent-based modeling has helped a lot of research institutes. Even you can just like even a Hajj. We know that Hajj, Mecca, Medina, right? Like that particular
Mhm,
like a like people are like doing research around like how we can manage the crowd in Mecca and Medina, or how we can manage the crowd or understand the crowd behavior in like Puri festival, like this. So
mhm,
there are like ability, like agent-based modeling has the ability to solve the social problem and also the industrial problem. So this might not
mhm,
be like so our intention of this TFUG and like AI Coimbatore intention is like there are like unique like solutions, unique technologies are available in the data science domain. We just wanted to
mhm,
bring that out to the beginners, right? So
mhm,
to and like classic models, classic solutions are still being used in business stakeholders, and they are giving good impact. So that should be
mhm,
understood, like the beginners should understand that we should like we should plan our steps gradually, right? Like we should learn linear regression, then move on to machine learning, then move on to deep learning. That will create a proper learning impact on the users, and also like we can easily sorry on learners, and also that can also be directly used for company related problem solving. So to get started with, like to where to get started with, the basic statistical modeling will help them. And in statistical modeling, these linear regression, and we are always like forget one thing, or like ignoring one thing, which is like a frequentist sorry that a Bayesian approach. We are always like concentrated on like frequentist based approach, right? Whereas in the Bayesian, which is like probabilistic approach, we have n number of models. Probabilistic deep learning is there, deep belief network is there, and this Bayesian network has like a lot of use cases to defining such like interaction between users to capture the consumer behavior. Like Fortune 50 companies or Fortune 20 companies are actually using that in the real time. A lot of like startups
mhm,
are building that building their frameworks around this agent-based modeling simulations and all. To get started with that, like I would suggest people to learn more about statistical modeling. That is what I'm like I'm actually like suggesting everyone, like concentrate on statistical modeling, take your time understanding these linear regression, linear mixed models, because one such things is linear mixed models, and the Bayesian networks. These things are like completely ignored or completely missed out by beginners. They are like, okay, linear regression, one such regression, okay, let's study that, let's move on to
mhm.
k nearest neighbor or decision tree. In between that
Definitely,
linear
yeah.
regression to decision tree, we have like penalized regressions, and we have like linear mixed effects models, support vector
Mhm,
regression, like a
mhm,
non-parametric regression things are there. These are all actually being utilized in the industry, right? So I would suggest that like ISLR will cover these things. Introduction to statistical learning will cover, and we can take some time, because being a beginner we have enough amount of time. If we are in industry, we will be having a lot of things to learn, a lot of things to practice, and a lot of things to cover. Whereas beginners will have like their own time in colleges, their own time in a training period, right? So this is one thing,
mhm,
and this has huge impact actually, because like we just concentrated on like transfer some transfer learning, or like importing some package and fitting some models. And okay, I've built some portfolio with the tie data set and applying for a company, where the company is actually looking for people those who are like good at problem solving, instead of just importing the
mhm.
package and fitting that, right? So that's
Yeah.
how we can become a unique person. Instead of concentrating on
Mhm,
framework, we can concentrate on kind of like problem solving. So that for solving that problems, we can take these kind of frameworks, these kind of algorithms to improve the performance.
Mm-hmm. Yeah,
Yeah.
thank you, Prabha. But that was really insightful. And the second question would be, like as far as I've observed, the code base is kind of built from ground up, like considering all the concepts and the agent-based simulation model, the code was. But is there any existing framework that we can right away use it in order to implement or execute these kind of scenario?
Okay, so there are two different types of frameworks. One is code-based frameworks, which is
Mm-hmm.
actually we need to handcraft everything, as in like as we see in that GitHub repository. We saw that all the agents are being like the behavior and the characteristics of the agent being written in the classes and objects, and everything is being written conditions, right? So that
Mm-hmm.
is one such thing, like using Python or R. In my agent based modeling project, we have used R to define that like agents and agents behavior, but here we have used Python to define that. So there are like Python based frameworks, Python based Mesa, Mesa, and NetLogo is there, which is like code based one, which is like Python based one. And we should handcraft everything, like agents and scenario, everything. But mostly this is not mostly like researchers, those who are good at sociology, those who are good at like this complex systems and all, they require, they are using more UI based frameworks, where they can just
Okay.
define the logics, they can just define the characteristics using them drag and drop, right? For that, there is a framework called hash.io, hash.io, and we have a NetLogo UI, and we have like NetLogo, any logic. So any logic is for any sort of like a discrete event simulation, like we can simulate any sort of like environment over there. So these three things, like hash.io, NetLogo is a like industry standard one, but nowadays a lot of competitors has come up. These like NetLogo, Mesa, sorry, not Mesa, NetLogo, hash.io, and any logic are the UI based one, which is being utilized by research institutes, and even by a few industry teams also. Why? Because like that is actually reducing the time in spending in time in coding, whereas we can concentrate on logics, we can concentrate on heuristics and research based approach, instead of
Mm-hmm.
spending time in handcrafting the classes and objects and writing some code and making it in modules and running it, right? So and these UI based things are come up with good computation infrastructure, like good
Mm-hmm.
clusters and like CPU cores and all. It's come along with that, because like
Okay.
when we like simulate like lakhs of agents, we would require more
Mm-hmm.
time and more HPCs, right? Yeah.
Mm-hmm.
Yes.
Great, great. Okay. So, and another question would be like, see, this agent-based modeling, and especially, it looks like a tool or a method for analysis. Okay, so where you pull in data and do some analysis and understand what is happening. So, are these solutions or deployable or consumer facing? Is it like, or it's different, where more of research based?
So it's a consumer based only, like so it can be done in a both way, like how we are
Okay,
utilizing regression for research and also for production, right? Like also
production.
for as in like real time utilization, the same way.
Mm-hmm.
This particular thing can be utilized for two things. One is understanding or researching about like one new environment or new system, and another one thing is like understanding that and to take the business decisions. For example, if I do this agent based modeling for a consumer behavior analysis, I can like
Mm-hmm.
utilize that ABM framework for new product launch. I can just take the new intervention, I can put the new intervention of new product launch, understand, okay, how this whole US or how this particular state of the US is going to like going to interact, are going to like um, kind of like perceive this new product launch. How are they going to accept it? Like whether will it change or whether will it cannibalize the existing product? That was our project. So we
Okay.
worked for Australian based CPG company, where we built a agent based modeling to understand the
Mm-hmm.
consumer behavior. If they launching a new product, what will be the scenario? How people will take it? If we are increasing the price, how will it change? Or if we are like we can it's like a control panel one, right? We can increase the
Mm-hmm.
competitive price also, and we can understand like how will that impact our sales. Likewise, we can play around it. As I said before, it is not a solutioning approach, it is a exploratory analysis approach to understand the
Mm-hmm.
ifs and buts in and out of the system, and using that we can take the decisions. Because we cannot imagine, like we cannot consider, okay, what will happen, what will happen, what will happen what will happen if we increase the increase the price, or if we reduce the right. So to understand that,
Okay.
companies are actually using it. CPG companies,
Mm-hmm.
banking, economic finance related firms are actually using it.
Mm-hmm.
There is a, so actually any logic, hash IO, they have good customer base, those companies.
Okay. Okay. Okay.
Yeah.
Great. And that's it, I guess. Is there any questions from the audience side? I think there are no such questions. Kind of, it's pretty. What to say? It's really hard for the beginners to wrap their mind around the idea of agent-based modeling, because they are used to model.fit and model.rank. That sort of doing machine
That's why
learning.
yeah, that's why we bring this up, like even so
Mm-hmm.
I've conducted a like just a LinkedIn poll, where I've like just asked like whether people my connection has heard about or have worked on agent based modeling or not. I could get like mostly like 70% of people didn't heard about that, didn't like work on agent based modeling. Why? Because like very few use cases are actually available in service sector, in
Mm-hmm.
analytics solution provider. But this has, so even if you ask people, those who have worked on reinforcement learning for a clients, it is very less. People are learning it, but it is not being widely used in industries. Very less
Mm-hmm.
comparatively to classic machine learning, right? That the
Mm-hmm.
same way, but this has like a lot of ability. Like if people could understand agent based modeling, the essence of that, we ourselves can build some sort of algorithm, like evolutionary algorithm. For example, data scientist algorithm, the same like how we have genetic algorithm, right? Like using the
Mm-hmm.
behavior of genetic mutation or reproduction, we are trying to solve for trying to use it for hyperparameter tuning, utilizing for some inventory optimization. It's the same way, if we could understand the behavior of data scientists, how are they actually
Mm-hmm.
learning, how are they actually like moving forward in their career, if we could
Mm-hmm.
simulate this in an agent based manner, and if we could translate this into an algorithm, we can use, or we can name this as a data scientist behavior algorithm, and we can use it for a real time industry solutioning, like
Mm-hmm.
optimizing something or finding some solution in the search space.
Yeah.
That, yeah,
Mm-hmm.
that's how this evolutionary algorithms are, like hundreds of algorithms are there. With just behavior of
Mm-hmm.
cat, there is an algorithm. Behavior of cuckoo, there is an algorithm. Behavior of elephant, there is an algorithm that is being utilized. But
Mm-hmm.
that is like the very minimal amount of people are exploring. We are
Yeah.
just stopping ourselves with genetic algorithm or particle swarm optimization. After that, a number of things are
Mm-hmm.
there to just to give that awareness around this agent and agent based systems. I've come up with this modeling, agent based modeling thing.
Sure, sure, Prabhat. It's a really exciting field to explore and also to learn as well. One last question. I think there are no questions from the audience side, but we'll take up like you can take up another question from me. So in meanwhile, if anyone is having any questions, they can post it on the comment. I'll not waste much of your time because you are already ill. I guess like you're kind of struggling. we'll have one last question. So if someone wanted to learn these stuff, like you have already recommended the statistical learning book. Other than that, what are all the good resources to learn these type of not non-conventional, but the other side of AI ML, which is much needed,
So can you
and
repeat
any
the
online
question?
resources or any
No, no.
online
Can you
resources like
can you
yeah
repeat the question?
resources, courses or blogs or YouTube channel where we can learn these like non ML or non deep learning, like the classic techniques. Any
So
of your
yeah,
favorite resources?
like I would say like Medium has all these things, like how agent-based modeling is being used, or how
Mm-hmm.
kind of like linear mixed models are being used. So Medium has wonderful resources, which
Okay.
we are hardly using. We are like utilizing more on YouTube channels. Whereas Medium
Mm-hmm.
has this one, like how it is being used for traffic management, how it is being used for crowd management and city planning. That is there. The same way,
Okay.
the like simulation perspective of statistical modeling, as in like instead of predicting something, we can use
Mm-hmm.
like linear models or statistical model as a brain for simulation. For example, if we could understand the relationship between um, the price and the sales, we can play around it, right? What will happen if I increase this price? Or the same way, like what will happen if I want to um, what should I do if I want to increase the consumer base? Like should I invest more on TV, or should I invest more on social media marketing? Like this, those decision related projects or decision centric things can be done using linear models or statistical models. And obviously we know that explainability is like high. These things are like pretty much white box modeling only, right? So that as I
Mm-hmm.
said, like ISLR will help, and uh, like um, uh, like Medium is one of the best resource, and YouTube, like that Net Logo and any logic has its own blogs where we can learn this agent based modeling and simulation related stuff. Because like
Okay.
in my professional experience, like I would have been a part of like some five or six major projects. Out of that, I worked on two projects which is around simulations only. One is consumer behavior simulation, and another one is inventory simulation, to
Mm-hmm.
simulate the each and every orders and each and every movement of like products in and out from the inventory. So yeah, that really helped the customers to understand,
Yeah.
to plan things, and to take decisions.
Yeah. Okay. Okay, Prabha. Thank you so much. And
Yes.
so that's it. We'll close in a minute or so. Before that, why can't you like Prabha? Why not you share your initiative like Learn with Karan and other things that you are doing? You can just do a screen share and explain the things whatever you're doing. It will be really helpful for others to follow you and learn from you as well.
Yeah. So, like I've been like collaborating with many kind of like data scientists with like some social cause and some interest, right? Like Navneet, people in TFUG, Coimbatore, TFUG, Chennai, right? The same, like likewise, we could see a lot of interested people in this community. I've been collaborating with them, and also I'm giving these kind of like very unique like webinars to universities, to working professionals, under the initiative of Learn with Karan. And you can follow me on LinkedIn, and you can follow my web page, where I talking more about these kind of like new technologies. It's not only unconventional ML things or simulation based one. This is one part of area, one sort of area of interest. I'm still like concentrating more on machine learning, deep learning, NLP kind of things. But let's talk this also. That was the intention behind that, so that like more and more people will get to know about ABM, agent based modeling, and will build some sort of like simple project around that. If you have any queries, if you want to collaborate with me, you can obviously reach out to me through LinkedIn or my website. And another one thing is like we are like interacting with people. We're trying to solve the problems that are faced by the beginners through clubhouse sessions. So where people are like coming in and asking their questions and putting their queries, and we are trying to solve that out, like for beginners and those who are trying for career switch, along with people in TFUG, AI Coimbatore, and other volunteers also. Yeah, you can catch me anywhere in LinkedIn, Clubhouse, website. Yeah, thank you. Thanks for the opportunity.
Yeah, Prabha, we got one question from audience. I think we can take it up, I guess.
Oh, okay.
Yeah, is it visible on your screen?
Yeah. Can you tell more about impact AI can create on architecture segment? Okay. Okay. So, with respect to architectural like segment, there are two things. One is, as an architect, we can plan a city, and as an architect, we can plan a particular interior designs or particular building, right? So, using the power of GANs, we can actually GANs are nothing but like a sort of generative model which has like a lot of power inside that. So like for example, if you're just giving a one some like your wish, okay, I want to build a 3-story building, and like 2 bedrooms, one hall, one kitchen, like this, it will try to provide you the optimal plan of the like of the architect like of the building. And that is one thing, and that could suggest you better interior designs, better like colors, and simply interior design, right? Two things, like designing the the building, or designing um, the project, and another one is like designing the interiors of things can be done using the GANs, which is like power of the AI. Like we can discuss about like architect GAN, ArchiGAN, I guess, which has the power of creating the like automatically that can create the architectural plans based on the customer, or based on the user input. Yeah, GANs are going to play a major role in this architectural segment, and other things like payment, planning related stuff, and some sort of like a resource allocation. So those kind of things, like other project management or other workforce management, can be utilized. But specifically to the architecture segment, this designing and optimizing the design and interior suggestions, recommendations will be like area to be explored, and area to be democratized and commercialized, because very less number of products are there. If you could build the product around it, that will also help. And we have market, big market for that in India or in anywhere in the world. But we need a
Yeah.
subject matter, right? We need a
Mm,
collaboration with architects.
yeah.
Yes.
So that's it, I guess. Thank you, Prabha. Instead of having a cold and also like you have handled the session
So,
for us.
okay.
Thank you
Yes.
so much. And people do follow Prabha on LinkedIn and Clubhouse. He has awesome content. It's just not for some personal branding or marketing. He really is a valuable speaker. You can learn a lot of things from him. And again, do stay in touch with us. It's not do follow or yeah, we are not leaders. We are also learners along with you. Stay in touch with us. You can connect with us on our Meetup platform, LinkedIn, and WhatsApp, Telegram, and other lot of channels. Thank you so much, and thank you so much for staying for throughout the session and until the end. And yeah, so without any thanks, Prabha, once again, and we'll close the session. See you again in another awesome session in the coming days. Thank you so much.
Yeah. Thank you. Thanks a lot.